So first of all, today we're going to talk about a bearing. So a bearing is just a type of angle. So it's an angle, but the key thing is that it is with the North Pole. So in other words, when we draw our triangle, we have to make sure the bearing is with the north. Okay, so for example, if I have this triangle right here, and I call this A and I call this B, which one of these angles is with the north, A or B? And if you can say the north would be with the vertical axis. So which one is with the vertical axis? B, right? So in this example, the way this triangle is oriented, the bearing would be this angle, okay? So I think it's the hardest part. And that's what we're going to work on today and Monday and also Tuesday. So we're just going to do a brief introduction of it today. The other thing to keep in mind is whenever you're asked to give a bearing, because it is an angle, we will have to use the inverse. For angles, we use inverse because angles are inside. So inside angles, or all angles are inside, but inside inverse, okay? And the last thing to keep in mind is whenever we have an angle, so I'm going to say, for example, let's say it's 57 degrees. I just made up that number. On the left side of the bearing, we put if it's a north-south, if the direction is north-south. So north or south will go on the left. And then on the right side is east or west. So east or west. Okay, so that's just a really generic and brief introduction to it, and we're going to use today. We're going to do about 4 questions, I think. We're going to do 1, 2, 3, and then we're going to skip over 4 and do 5 and 6. So we got 5 questions we're going to work through today. All right, so let's look at question number 1. So question number 1 says that we have an airplane. The airplane is 80 miles south and 95 miles east of Cleveland. What bearing, again, that's my angle, should be taken to fly back to the airport? So have you ever heard of never eat soggy waffles? Never eat soggy waffles. I still write that out every time I make my little compass, so I can remember my directions. I'm directionally challenged. Like if someone say go north, I'm like, what does that mean? I don't even know. Okay, so we have an airplane. The airplane is 80 miles south and 95 miles east of Cleveland. So I'm gonna say Cleveland is here. So this airplane went south, so that would be this direction, right? It went south 80 miles, and then it made a turn and went 95 miles to the east. So that would put the plane about right here. So let's say that it wanted to go back to the airport. So now we're going to travel heading back to the airport. That would be this direction. So that's my triangle. So the tricky part right here is even though the plane is right here, this cannot be a bearing. And why can't that angle be a bearing? Because it's not with the vertical. So this is an example of where we have to extend our triangle. Our bearing will be outside. So the bearing in this example is actually right here. That's my bearing. Right there. So the thing about a triangle, obviously, is that it's half of a rectangle. So even though I have reoriented my triangle and made it upside down, those sides or those distances still apply, except so I can put that 95 here and the 80 here. So if that's my bearing, what is the 80? Is the 80 opposite, adjacent, or the hypotenuse? Adjacent. Good. So I'm going to put 80J. And what about the 95? What is that? Opposite. So what trig ratio am I using to find my bearing? Tangent. Good. So tangent of my bearing equals opposite over adjacent, which means that the bearing, because remember, angles, we have to use the inverse, is the inverse tangent of 95 over 80. And we'll just go to the 10th place, so. It's not working? Just put that on my desk. It just needs some batteries. And it takes like 9 screws, so I'll just put it in the office. Let somebody else. So what did you get when you typed in inverse tangent 95 over 80? 49 point what? All right, who got 49.9? Okay, so remember, whenever we're talking about a bearing, though, we have to use direction. So let's look at this. So originally the plane traveled southeast. So to go back to Cleveland, what direction would it have to fly? Northwest. So we have to put the north. North has to go on the left. West has to go here. So this is how you show a bearing. That looks like a W, both of those. Let me make a better N. Okay, that's better. So whenever you're writing a bearing, you have to include direction. So that would be my final answer. All right, let's look at question number 2. So it says a ship leaves port and sails. So I gotta put my never eat soggy waffles here, so this helps me with my diagram. All right, a ship leaves port and sails 12 miles to the west. Then it turns and heads north for 20 miles. So we went west. First we went this way, west, for 12 miles. And then it went north for 20 miles. So this is where we started. So we started at the port. So this is my ship. So the ship, because the ship is going north, when it makes its turn to head back to the port, do you see how this angle where the ship is already at the north? So I don't need to make my upside down triangle. Okay, so that is my bearing. So go ahead and find the bearing. That angle right there.
Wait, can you say again why?
Okay, so if you look at this one here, see how the plane, the last direction it went was east. So I had to draw, this angle here would not be the bearing. I had to make another triangle upside down to get my angle. A bearing has to be with the north. Has to be with the north or south. So for this one, I was at the port. We went here, here. But where my ship is located right now is with the north. So again, we know that 12 is opposite and 20 is adjacent. So the tangent of my bearing is 12 over 20. So theta is the inverse tangent of 12 over 20. So you get 31 degrees. So we get 30.964. So I round it out to 31. And what's my direction? Because we started off going north and west. So the opposite would be southeast. Good. So we have south and then our east. And that is our bearing. Okay, what y'all want to ask me? What's the question?
She wants to know, does it matter what order you put it?
What, the southeast?
31 degrees.
Okay, so that's a good question. You always have to put on the left, has to be north or south. So north or south has to come first. East, west has to come second. Oops, wrong thing. Yes.
So when we're finding the like south or east for the insert, so since the angle is starting up there in the northwest, it's just going to be the opposite directly from
Right. So if you look at it this way, this is my ship. So if you think about the never eat soggy waffles, it's heading this direction, which is southeast. So the ship is coming southeast to head back to the port. All right, let's look at question 3. So number 3 says we have an airplane and the airplane is 30 miles northeast. So notice how we have northeast. That tells me right now, if I'm going northeast, I'm going at a diagonal. Okay. If it was north or just east, northeast tells me that that 30 has to be the hypotenuse. So I know that this 30 is going to represent the hypotenuse of my triangle. So I have, again, let me put my little compass because, again, I'm directionally challenged. I had to write this every single time. So if I'm going, the airplane is going northeast, that means it's heading this way. That's northeast from the airport. So this is my airport. And the plane is going northeast. 30 miles. The angle of depression, now, again, notice this time, does it say bearing? It said angle of depression. Angle of depression is always with the horizon. So right here, an angle of depression, going back to our lesson yesterday, we have an upside down triangle. So when I see those words, angle of depression, I know that I'm creating a triangle that's upside down. And that angle of depression right here, that's going to go here. That's your angle of depression. 30 is my hypotenuse. And it's asking me to find the plane's altitude. So altitude is another word for height. Which would be right here. The height of the plane from the airport or from the runway. This is the height. So using this triangle, what trig ratio do you think we're going to use to find this x? Sine. Who agrees? Sine. So we know that 30 is my hypotenuse and x is opposite. And we're not trying to find an angle, so we're not going to use the inverse, okay? So we have sine of 32.5 equals opposite over hypotenuse. Go ahead and solve this. Solve it for x. All right, so when we cross multiply, I get 1 times x equals 30 times the sine of 32.5. Go ahead, type that in your calculator. see what I got. 30 times the sine. I got 116.1. Nope, sorry. 16.1. I don't know where I saw 100. I saw an extra one. Sorry. I got 16.1. Anyone else get 16.1?
Yes.
What's the unit? Miles. Don't forget units. If it's a word problem, minus half a point.
And this one doesn't need the directions.
All right, so first of all, are we finding an angle? No. And it wasn't a bearing. The only time, so when you see that keyword bearing, find the bearing, that's when you have to use the direction. All right, we're going to skip over 4 because 4 has a whole lot of. And we're going to jump, we'll do that Monday when we got a fresh mind. Let's do 5. 5 and 6, and then we'll end there. So question number 5 says we have an airplane. The airplane is 15 miles from the airport at a bearing of north 62 degrees west. All right, so we got our never eat soggy waffles. All right, so it's telling us that we're going northwest. So this airplane went northwest. Right here, so northwest. And then I'm gonna just draw, because our bearing has to be right here. So that's 62 degrees is going to be on the outside. It's 15 miles from the airport at a bearing of north 62 degrees west. Oops, sorry. Oh, okay. Tion. Okay. So that 15 degrees, because it's with our bearing, we know that's our hypotenuse. And what it's asking us to find is asking us to find 2 things. It's asking us to figure out how far west and how far north. So this is my triangle. And I need to figure out how far west and how far north is this airplane. So this is my airport. And this is my plane. So we need to use 2 different trig ratios in order to find this. No, yeah, there we go. Just making sure. All right, so if I'm trying to find north, let's go ahead and label all sides of our triangle. Okay, so north would be what? Is that opposite, adjacent, or the hypotenuse? Adjacent. And west is what? And that 15 is my hypotenuse. All right, let's go ahead and find north first. If I'm trying to find north, what trig ratio am I going to use to find north? Cosine. Yeah, because north is adjacent and I'm using the hypotenuse. So to find the north is going to equal the cosine of 62 equals north over 15. So let's go ahead and solve that for north. So again, that's a ratio. So north should equal 15 times the cosine of 62 degrees. So let's go ahead and type that in your calculators. And who got 7? It's like 7.042, so I'm just going to say 7. And it's 7 miles. Now, that's not the bearing. That's just how many miles north. So the plane is 7 miles north. So I think you're doing the other one. So to find west, what trig ratio am I going to use to find the west? Because the west is opposite in the hypotenuse. So we're going to use sine to find the west. Sine of 62 equals opposite over the hypotenuse, which means that the west is 15 times the sine of 62. All right, go ahead, type that in your calculator. Now that one should be 13. I got 13.2. So what this question was asking is they gave us the bearing and the hypotenuse, and they wanted us to find the other two sides, the north and the west. All right, I want you to try to do number 7 by yourself. No, not number 7, sorry, number 6. And then we'll end there. Try to do number 6. And then we'll end with that question. Do you have a question, Chris?
So that's all we had to do for the bearing?
So we're not trying to find the bearing. See, they gave us the bearing. That's the bearing. They wanted to know, so the question said, how far west, so that's the length of that, these are lengths of sides they wanted us to find. They wanted us to find the length of this side of our triangle and this side of the triangle. We had to find two side lengths.
Is the bearing always outside?
So the bearing should be with the north. Yeah, has to be with the north.
Yeah, okay, because I made it go west to this.
No, so it just depends. It depends. It depends on how you draw your triangle. So the main thing to keep in mind is the bearing should be with the north. So when you're drawing your bearing, it should be with the north. So I think, this is my third time going through this lesson, I think most of the students drew an upside down triangle, like first and second period did. So I don't know if you all did too. So here, 65 north. So 65 miles north. This is north. Do we all agree that that arrow is going north? All right. And then if I'm going west, I go this way. Right? So that would be 45. So here's the thing that you need to keep in mind. Oops, I messed that up. That's horrible.
I did west too.
Okay, here's the thing though. If you stop right here, let's say you said, okay, is that angle, could that be a bearing? No. And why can't it be a bearing? Because it's right. So what you'll have to do, you're going to have to extend your triangle and put that on the outside.
Wait, why couldn't you put it on the inside since it's vertical?
Okay, so right here, this angle here, so a bearing has to be with the North Pole. This angle that I have here, this yellow angle, is not with the North Pole. It's going up. The angle has to be with your vertical.
You can't put it with that line?
Oh, here? So the plane though, if you know, because right here, so the plane, that's the airport. So this is the airport. And the plane is here. So you have to put that bearing closest to the airplane. Okay, so here, oops. Okay. So again, we have our 65, which can also be here, and we have our 45, which is here. So for our bearing, the 45 is opposite, the 65 is adjacent. So the tangent of our bearing is 45 over 65, which means that theta is the inverse tangent of 45 over 65. And what is 45? What's the inverse tangent of 45 over 65? 34.7. Who got 34.7? All right, so this is what I want to make sure you understand. If the question is asking you, you see how it says what bearing? So the question we're answering is what is the bearing, right? What do we have to include with our answer? Yeah, we have to include the direction. So if my bearing is 34.7 and I started off traveling northeast, what direction am I going to travel coming back? Southeast. This is your answer that I'm looking for your bearing.